Hello everyone, welcome to Pepcoding. So in this video, we are going to discuss the question, count pairs with XOR in a range. So basically, we will be given an integer arrays and two integers, that is low and high, and we have to count the number of pairs for which both of these expressions are satisfied. Which expressions? This. See. So basically, we will be discussing all these points. So let us start. So basically, we are given an array of integers. Suppose the integer values are 1, 4, 2, 7, and we are given a low and a high range. So suppose low value is 3 and high value is 5. So basically, what we have to count in this, we have to firstly count the pairs, and also that pairs, what kind of pair should it be? It should be the pairs in which, if we have selected two numbers in a pair, then doing the XOR will result in something that should come in a range. So having the XOR of two numbers, that is a pair, will give a result, and that result should be in the range. So that range should be greater than equals to low and less than equals to high. So this is what question is saying. So we have to find all such pairs. Suppose we are given four numbers, that is four integers. So the integers are 1, 4, 2, 7. And if we'll have pairs, if we want to get the pairs, then the pairs will be 1, 4, 1, 2, 1, 7, 4, 2, 4, 7, and 2, 7. See, pairing is done like this: 1, 4, 1, 2, 1, 7. If you say that the pair is also 4, 1, then definitely this is also a pair. But this is the permutation of this pair. So we have to avoid permutations. Okay. So if the pair is 1, 4, then we will not include 4, 1, 4, 1. Or if the pair is 4, 2, then we won't include the pair 2, 4. Okay. These are the permutations. So now, if we are having these pairs, then what we have to do? We have to select the pair. Firstly, we have to do XOR of that pairs. Okay. So 1 XOR 4 will result in 5, and 1 XOR 2 will result in 3. 1 XOR 7 will result in 6. 4 XOR 2 will result in 6. 4 XOR 7 will result in 3. This will result in 5. See how? So let us see a table of binary conversion. See, if we are having decimal numbers 1, 4, 2, 7, 3, 5, then their binary conversion is this. 1 is equivalent to 0, 0, 1, 4 is equivalent to 1, 0, 0, like this. And if we have to perform XOR, then let us select a pair 4 XOR 2. Then how we will perform this? Binary equivalent of 4 is 1, 0, 0. Binary equivalent of 2 is 0, 1, 0. And what we have to do? We have to perform XOR. Performing XOR operation, this will result in 1, this will result in 1, and this will result in 0. So now 110 is the decimal equivalent of 110 is 6. 1 into 2 plus 1 into 2 plus 0 into 2. 0, 1, 2. So 4 plus 2, that is 6. So binary equivalent of decimal equivalent of this binary number is 6. So ultimately 4 XOR 2 will result in 6. So this is what we have written. So Now we'll check whether this result after doing the XOR, this comes in this range of 3 and 5 or not. So we'll check. 5 is in between 3 and 5. So this is 3. So result must be greater than equals to 3 and less than equals to 5. So this will count. This also will count. We won't count this. This will count. This will count. Okay. So there are 4 such pairs. Out of all 6 pairs, there are 4 such pairs in which after performing XOR operation, this comes in the range of 3 to 5. So for this, our answer will be, count will be 4. Okay. Now, if we'll think of the approach of solving this question, then the brute force method is what? Suppose we are given some number 1, 4, 2, 7, 9, 6 and we have to find such pairs in which after performing XOR this comes in a range. Okay, so what we'll think? We'll think that first select a number at index I and what we'll do? We'll start pairing with we'll start pairing this number, this integer with its forward indexes. Like if this is the ith position, then we'll XOR it with I plus 1, I plus 2th till n minus 1. Suppose they are the n integers. Then this is the indexing 0, 1, 2, n minus 1. Then what we'll do? If we'll select this number, then we have how many options? If we'll select this 0th position, then we have n minus 1 options. And if we'll select this one number, this at the number at 1th position, 1th index, then we have n minus 2 options to do the pair and we'll checking with each of them. And for the number at 2th position, we have n minus 3 options. Just like this, we will have only one option, that is this and this. So adding all these will result in basically summation of this will be basically this. So this will give something complexity of n square. Okay. So this method, if we'll solve this question with this approach, this brute force method, then it will result in time complexity of n square and we have to minimize this complexity. How we'll minimize this complexity? This is the brute force way. We'll implement the concept of trials. How? See, before moving to the implementation, let us discuss some points which we'll be using while implementing our approach. So these are the small concepts. So what are those? If we want to check two numbers, whether the numbers are in range or not. So see what we have to do. Firstly, we have to XOR two numbers and the result will check whether this result is in range or not. So for this, if we'll take two pairs like 4 and 2, then binary equivalent of 4 was 100 and of 2 was 010. Okay, so what we'll do basically, so we are checking for 4 and 2. So this is 4 and this is 2. If we'll have the most significant bit of 2, so most significant bit of 2 is 0. This is most significant bit. So if we'll XOR this most significant bit, then the result will be 1. And if we are finding for the range less than equals to 5, that is 101. So what we'll do, we'll compare this one with this one. So are these is this number less than 1? So no, it is not less than 1. So what I am trying to say over here, that finding the XOR of most significant bit will not cannot decide whether the whole number will be less or smaller. See, before moving to this, first understand a thing. Like if we are having numbers 2, 3, 5, 9, this is number 1 and this is number 2. Like 4, and if we are asking which number is greater, then how can we find which number is greater? See, if we'll put 1 over here, no matter whatever comes after 1, doesn't matter. While checking this one only, we can decide that number 2 will be smaller than number 1. Okay, can we say that? If we are having a number 2359, 2359, and we are having a number which is starting with 1. Okay, suppose this will be of 4 digits and this will be also of 4 digits. I'm talking about the same number of digits for same number of digits. So if the number starts with 1, can we decide whether which number is larger and which is smaller? So yes, we can decide this is 1, no matter whatever comes after 1, this number 2 will be smaller. But if we say that the first digit is 2, then can we decide which number is smaller or greater? No, we can't decide because both the digits are same. Similarly, if this digit is 3, then we'll compare this digit. Here also we can't decide. But if this number is 4, then yes, we can decide. How? This digit is lesser than this digit. So we can simply say that number 2 is smaller than number 1. So if we have 6 over here, then also we can decide that number 2 will be, no matter whatever digit comes after 6, the number 2 will be greater than number 1. So this is what I am trying to say. So here also we will compare the same thing. If we have done the XOR of most significant bit, we have received 1. So can we decide here whether this number will be in the range of this or not? So we can't decide because this digit and this digit is same, for which we are comparing, both the digits are same. Okay, now for 2, the next digit is 1. So we'll place 1 over here. This will XOR of these digits will result in 1. So now can we decide this number will be in the range or not? Yes, we can decide because on comparing these digits, this digit is greater than 0 and we have to find less than this range, within this range. So we can simply decide in this position only that this number will not be in the range. So we won't be checking for the next digits. Okay. So this is the efficient method to decide whether the number will be in the range or not. Okay. See, this we have decided for less than equals to 5. What if we have to check less than equals to 5 and also greater than equals to 3? Then for this, let us understand a thing. See, we have to find whether the result is less than equals to 5 and also greater than equals to 3. So let us focus on the thing that suppose we are given some numbers like 3, 5, 7, 2, 1, 8, 7, 6, 4, 3, and the low value is 4 and the high value is 7. And if we have to decide the number of the numbers, if we have to decide the count of numbers which are in between this range, then firstly what we'll do? We'll count the numbers which are less than equals to 7. So for that, less than equals to 7 numbers are 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this count will be 9. And if we have to see, right now I'm discussing the brute force method to find the the numbers in between, count of numbers in between this range. So this is not the efficient method, but we are discussing to understand the efficient method more clearly. So less than equals to 7. Now we can do what? Out of all these 9, we can select the numbers which are greater than equals to 4. So that will be greater than equals to 4 will be 5, 7, 7, 6, 4. So such numbers are 1, 2, 3, 4, 5. So such numbers are among these 9 numbers, the range numbers will be 5. Okay, can we say that? But here we will use another method. What method? We won't be counting for the numbers which are greater than equals to 4. What we'll be doing rather than, we'll be counting the numbers which are less than equals to 3. Why 3? 4 minus 1. 3 means 4, whatever low value is, 4 minus 1. So what this will do, basically, if we'll count the numbers which are less than equals to 3, then what we'll be doing? We'll be subtracting these count. Whatever will come, in this answer, suppose the numbers less than equals to 3 are this one, 2, 1, 3 is also less than equals to 3. So this 1, 2, 3, 4. There are 4 such numbers which are less than equals to 3. Then we'll do what? For counting numbers greater than equals to 3, greater than equals to 4 and less than equals to 7, what we'll do? We'll subtract the count of numbers which are less than equals to 7 and count of numbers which are less than equals to 3. So basically this will give 9 and this will give 4. Ultimately we will be getting the correct answer, that is 5. Okay, so we'll be finding the numbers in range with this method. We'll be counting the pairs which which is less than equals to 7, and we'll count the number of pairs which result in less than equals to 3, and we'll be subtracting whatever we received from count of 7 with the count of 3. So now for this example, if this we have discussed for the general example, now we will be discussing the things for this example. So how we'll implement this thing? See, if we are checking for 1, then what we'll do, if we are checking all pairs of 1, that is 1s or 4, so let us move this thing. Okay, so we are discussing for this example. So if we will, firstly what we'll do, what we'll check for all 1 pairs, that is 1s or 4, 1s or 2, 1s or 7. And now for this, what we'll do, we'll count the pairs which are less than equals to 7, less than equals to 5, and we'll count the pairs which are less than equals to 3 minus 1, that is 2. So we'll subtract these things, and this will give the pairs which are in the range of greater than equals to 3 and less than equals to 5. So this thing we have discussed right now. Now we'll be discussing over this. So what we'll be doing, basically, see, in try, if we'll store these numbers, if we are checking for 1, then if we have stored 4 to 7, how will the data will get stored? See, firstly, if we will see for 2, 0, 1, 0. So like for 4, 1, 0 and 0. For 7, 1 and 1. So now if we'll check for 1, that is for 1 it is 0, 0, 1. So how we'll check? We'll check the most significant first. Most significant bit for first. So this is 1 and this one is 0, 1, 0 is 2. Suppose we are checking for 4 first. Okay. So for 4 it will be 1, 0, 0. So how we'll check this thing? We'll check for firstly for 4, then 1 or 4. We'll be checking for the range less than equals to 5. So we are basically now checking for the count of less than equals to 5 range. So this 5 is 1, 0, 1. So firstly we'll do the XOR. So this will result in 1. So can we decide whether this will come in range or not? No, because this is bit and this bit is same. Now we'll do XOR for this. So now can we decide? No, we can't decide because this bit and this bit is still same. Now we'll do the XOR for this. So now can we decide? No, because this is same. But now the number is completely scanned. So here this is equals to. So this will come in range. So here count will become 1. Means we have counted one such pair which comes in the range of less than equals to 5. Now we will compare for 1 and 2. So this will be 0, 0, 1. This will be 0, 1, 0. So we have to compare with 1, 0, 1. So 0, 0 will give 0. So can we decide this range, this will come in this range or not? Yes, this will come in range because this is 0 and it is less than. So we need not to do the XOR for rest of the digits. Here only we don't need to have this answer. We generally need this count. So we'll get our count from here only. We don't need to do the XOR for rest of the digits. See, it might come in the mind that this digit is not too long. Why are we putting so much effort in finding this XOR of rest of the digits? So it does, see, in this particular example, we are taking 3 digits, but it doesn't mean that always we will be having only 3 digits. The number can be, see, in the range of like 2000. So for 2000, we'll be having a lot of digits like 0, 0, 1, 0, 1, 0, 1, 1, 0, 1, such digits. Okay. So for finding at that time, for finding the XOR, for finding the result in the range, we need to have a lot more numbers. So this is the efficient method that instead of doing the XOR for all the digits, we can decide after doing the XOR for only 4 to 5 digits. Okay, so this will save the time. So that is why I was saying this is the most efficient method. Okay, so I hope you have got this thing. So now we'll come back to our solution. So this will so finding the XOR of this most significant bit, we can decide that this number will be in the range. So count will become 1 plus 1, that is 2. Okay, previously it was 1, now it is 2. Now again checking for 1 and 7, 0, 0, 1, 7 will be 1, 1. So we have to check for less than equals to 1, 0, 1. So doing XOR for 0 and 1 will result in 1. So can we decide? No, we can't decide. So again we'll do for second. This will also be 1. So now can we decide? Yes, we can decide. Here we will not increment the count. Why? Because this will not come in the range of 1, 0, 1. Here the this bit is greater than 0. So here count will still remain 2. It will not get incremented. Now we are checking for count of less than equals to 2. So for less than equals to, for the range of less than equals to 2, that is for 2 it will be 0, 1, 0. Now finding XOR for 1, 4, again 0, 0, 1, 1, 0, 0. So this will be 0, 1 will be 1. So can we decide here only that this digit will be less than, sorry, this digit is greater than this digit. It means this number will not come in the range of this. So now again for 1 and 2 similarly. So this will be 0, 0, 1, 0, 1, 0. So this will result in 0. So can we decide that this number will be in the range? Right now we can't decide because this digit and this digit is same. Now we'll do for this thing. Now can we decide? No, we can't decide because this digit and this digit is same. Now doing XOR, can we decide? Yes, now we can decide that this number is greater than this number. So this will not come in range. So for count of less than equals to 2, we don't have any count. Okay, still the count is 0. Here also count is 0. We haven't found any of the pair which is in the range of less than equals to 2. So now for 1 and 7, we will be checking 0, 0, 1 and 1, 1, 1. So less than equals to 1, 0, 1. Doing XOR, it will be 1. Doing XOR, it will be 1. Now we can decide that this number is greater than this. So this will not be in range. So count is still 0. So for pairing of 1, we have count equals to, that is of less than equals to 5, we have 2. Of less than equals to 2, we have count of 0. So basically we are having 2 such pairs. What are those pairs? 1, 4 and 1, 2. 1, 4 and 1, 2 are such pairs of 1 which are in the range of 3 to 5. Okay. So this thing we have discussed. Now for removing duplicacy, what we will do basically, we were having these numbers. So for the try, if we have done the work of 1, then we'll insert this one. Now we'll do what? We'll make pair for 4 and 1. So if we have 1, 4, 2, 7, then we'll do what? We'll do pairing of 4 and 1. Then we'll do pairing of 2 and 1 and 2 and 4. So how? If we have 1, 4, 2, 7, then we'll have 4 and 1. Then we'll have 2, 4 and 2, 1. And for 7, we'll have 7, 2, 7, 4 and 7, 1. So basically, we'll be having only 6 pairs. And after that, all the pairing are completed. So we'll be removing the duplicacy in this way. So for this question, we have discussed all the concepts which we'll be using in the code while implementing. So now let us implement the approach in our code. So basically this is our function of count pairs. We'll be returning our count value from this function. So let us start. So our very first step is we'll be creating a root of type node. So what this node, so we'll be also be creating a node class which will be containing left and right and value of count. So basically we are creating a root which will be having a left, a right and a value of count, integer count. Okay, and this will be also of node type, this will be also of node type. So class node will be having a left, a right, and initial value at these will be null ptr and the int count. Initially it will be 0. Now our next step is we will be extracting each integer from our array of nums. So we will see, we were given integer array nums. So in C++ we are using vector to implement the arrays. So we'll be extracting the value from this vector. Now we'll be counting pairs. So, and we'll be making a function query. We pass the root and high value and our extracted value and one more thing. So first understand what this will give. This will be counting the pairs for this value. For this value at range of high, means at range of less than equals to high, which was 5 for our dry run. We have discussed high value as 5 and low value as 3. So for less than equals to 5 range, we will be counting pairs for this value. Okay, and one more thing we will be passing, that will be max bit. So what this max bit means actually, let us discuss over this. So as you can see here in our question, the constraint is given that our value of nums can be maximum 2 into 10 raised to power 4. That is, we can say 20,000. So like we are having values 1, 4, 2, 7. Like this we can have 20,000, 10,000 and 2,000 and so on. So maximum it can be 20,000. So to represent 20,000 in binary, we'll need 15 bits. So we'll need 15 bits. Like to represent 7 in binary, we need only 3 bits. That is 111. To represent 20,000, we will need 15 bits. So to represent each bit with indexes, we will be having 0 to 14 indexes. Okay. So we will be passing this max bit as this 14. This 14. Suppose we are given a value 1. So how we will represent this 1? We will be writing 0 till 14 times and then 1. So to represent 1, we will be writing like this. Okay. So that is why we have passed the max bit. We will be passing this max bit value as 14. So now we have counted for range less than equals to 3, sorry, less than equals to 5. Now we will be counting for see here will be passing, so this will remain value, this will be low minus 1. Why? See, while discussing the explanation part, we have discussed this thing that when we were finding the result, that is pair, which is from range less than equals to 5 and less than, sorry, greater than equals to 3 and less than equals to 5. Like we have discussed some elements, and in that our high range was 7 and our low range was, see, our high range was 7 and our low range was 5. So we have discussed a thing. Okay, so our high range was 7 and low range was 4. So what we have done basically, to calculate the elements between this range, we have counted the elements having range less than equals to 7 and counted the elements having range less than equals to low minus 1. So what we have done, we have taken the difference of counting the pairs which are less than equals to 7 and minus counting the pairs which are less than equals to low minus 1. So same thing we'll be doing over here. We have passed the high, and in this function we are passing low minus 1. So after this we'll be calling a function insert, and passing the value of root, we'll insert the value for which we have counted the pairs. For that value we have inserted that value, and at last we'll be returning count. So now we'll create the function insert first, and also we'll discuss what this insert function is doing. So void insert, we'll pass the root value for which, so basically we are implementing try over here. How? This will start from 14. Why 14? Because our max bit was 14. So this will be greater than equals to 0 and I minus minus. So it will be creating mask. See, I hope you are familiar with basic bit manipulation. While implementing tries, we have discussed this many times. So if you are not familiar, then go and watch the video of basic bit manipulation. So you will get the behind working of this task. Whatever we are doing here, we are creating mask, we are taking AND. So this is basically convert into bit. We are basically converting our value into bits in binary form. So if this value is greater than 0, then we'll return 1, otherwise return 0. That means our bit will be 0. So now we'll check if bit is 0, then we'll be inserting at left. So for inserting, first we'll check whether the left is null or not. So if left of root is null, then we'll be inserting that bit in our left. So insert new node. Now point the root to left. Same we'll do one more task we'll do for the else part. So here what we'll be doing, if the bit is 1, so we'll be inserting at right side. We won't be discussing much on this insert function. I'm just giving an overview what this function is basically doing. See, for insert function, if we have given some value like in the array we were given 1, 4, 2, 7, low was 3, high was 5. So if we are checking for the value 1, if we have to insert this 1, how we'll insert this? Firstly, we'll convert this 1 into binary. So this will be converted like 0, 0, 0 14 times, and then at last it will be 1. So for now, we are not discussing on this max bit. We'll take this max bit as 2. Why 2? Because our maximum number is 7. So this will be represented as 111, and this will take only 3 bits. So when our high range was 20,000, it was taking 15 bits, and now it is taking 3 bits. So it will take max bit as 2, and for 15 it was 14. So here we are not discussing much on 14 times 0 and then 1. See, if we have to insert, we are creating the bits of 1. We are converting this into binary. Then first bit will receive as 0. So we'll insert that. If bit is 0, then we'll first check it left. If left is null, then we'll add this node in left and root will be pointing to this left. So now left is not null, right is still null. Okay, now again we receive the bit as 0. We'll insert this and we'll make this as 0. So count will become 1. Here also count will become 1. Left is not null, right is null. So here also when we'll receive 1, then we'll add it right side. So now root is pointing to 1. And like this we'll be inserting the bits in our insert function. So we have discussed the insert function. Now we'll be creating our query function. So what we'll pass in our query function? See, root and a high value, the value and max bit. So max bit, root and a high value and a value and a max bit, which will denote as index. So now our next task is we'll be creating bits for value. For this value we'll be creating bits, and for this high we'll be creating bits. So bit for value, we'll first create bits for value. So that will be val and left shift 1 till which index? Till index, whatever the value of index is. So if this value is greater than 0, then bit will be 0. Sorry, if this value is greater than 0, then bit will be 1, otherwise bit will be 0. Similarly, we will do for the high value. So bit for high, bit for high. So same thing we are doing for the high. Now our next step is we'll be checking this value bits. So if bit value is 0 and also the high bit is 0, then we have to return whatever we'll receive from this query function. Query will have now left and high will remain high, value will remain value, index will be decremented by 1. Else if high bit is 1, then we'll return query right of root and high and val. See, if you are not getting this thing, then no need to worry, we'll be discussing this whatever we are doing here. So also we'll get the count. So we'll be creating a get count function which will be returning the count at that particular root. So in node we were maintaining count. So this count we'll get by this function get count, and we'll be passing the root value. So that root we'll be getting from right. Sorry, we'll be getting this from left. So what this function is basically doing, we'll also create the else part. Similarly, So if this bit is 0, we'll be calling from right, we'll be counting from right, and in this we'll be calling from left. So what this function is basically doing, see, if we have passed the value as 1 and high value was 5, so what is happening, the bits of value is created. Suppose that let me write 1427 bits corresponding to 1001, 100, this will be 010, this will be 111, and for range 3 will be 011, for 5 it will be 101. Now if value is 1, so bit v corresponding to index 14. See, we are not taking index 14. Why? Because we have discussed that for range of 20,000 we were taking max bit as 14, but here the maximum is 7. So we'll take index according to 7 only, just for the sake of dry run. Otherwise our dry run will go too long. So we are taking index as 2, because we have maximum 3 bits to represent 7. So we are taking index as 3. So at index as 2. So at index 2, value 1 will correspond to 0. So indexing 0, 1, 2, it will correspond to 0. And at high value, it will be pointing to 1. So this is 1. Now we'll check if bit value is 0 and high value, bit high, is also 0. Then we'll be calling from left. See, if we are given some values like 0, 1, 1, 0, 1, 0, 1, 0, and 1, 0, 0, and 1, 1, 1. And if we have to check the bits, like if for 0, if we have to check in range of 1, so this is high and we have to find in range. So for this, here will be also some value for which we will be doing XOR. Here high value is corresponding to 1. So if we'll have 0 over here, it means it will return 0. So that will, if we'll have 0 over here, this XOR of this 2 will be 0. So this will be in the range. So it means if we are having some count over this 0, that is, if suppose it is 1, then we can say that all the numbers starting from 0 will be in this high range. How? Let me repeat it. See, if this number was 0, and we have to find whether this second number, count of this second number, which will make pair with this number, this value, and will also be in the range of high. So how will we check? If this is having 0, it means it will return 0. XOR of these two will return 0. And no matter whatever comes after 0, this will be in the range of high. So it means whatever the count, suppose it is having 0, 0 and 0, 1. So then also, if count is equals to, for this count will be 3. So for this, such pairs will be 3. But for now, when count is equals to 1, for 1, there will be a pair starting from 0, which will be 1. Okay. So we won't be checking after that. So now, for this particular dry run, we are having high as 1. So if value is also 0 and high value is 0 and high bit is 1, then we'll get count from left of this. So this is basically left and right. So we'll get value from left of this. So left of this is 0. So initially at first point it is having nothing. Its count is also 0 and it is pointing to null. This is also pointing to null. Okay, and this value is 0. So at first step, see, we have called the function from here. So here root value is pointing to new node, and that its left is containing null, right is containing null, count is 0, and we have passed our value from here. So now we'll be checking this. So we'll get count from left. So left is pointing to null, and we'll pass this left in our get count function. So we haven't created our get count function. So let us also create our get count function. So int get count. We have to return if this root equals to null, then we have to return 0, otherwise return the count of root. Okay, so now see, we have checked, we have passed our root dot left of root, which is pointing to null, so this will return 0 from here. Now we'll query for right. So we'll pass right, which will be null. So we'll get trapped in base conditions. So we'll be also be creating the base conditions. So till now we haven't created base conditions. So base conditions will be if root is pointing to null ptr, then return 0. And second base condition is if index equals to -1, then return whatever we receive from count. Get count function will call, we'll pass our root value. Okay, so now what happens, we received 0 from this get count function and we have passed root of right, so it is pointing to null, so this will get trapped in root conditions. Okay, so it will return 0. This function will return 0. We'll put this statements over here. So from this, for the first time when we are calculating for 1, so insert function has inserted nothing. So we have only root as having left as null, right as null, and count as 0. So we haven't got any pair for 1. Till now we haven't got any pair for 1. So we have returned 0 and this 0 will get over this count. So we have called from here. So again when we count query function for less than equals to 3 range, less than equals to 2 range. Range was 3, low range was 3, 3 minus 1 is 2. For less than equals to 2 also we'll get 0 in our count. So now we'll insert value. So value was 1. So when value is 1, we'll insert in this. So it will get inserted, 1 will be converted into binary, so 0 will get inserted, 0 will get inserted, and 1 will get inserted. So count will become 1 over here. See, in our insert function, we'll be also updating our count value. Count of root will be incremented. And here initially count will be 0. So we are done with first insertion. Now for the second time, this loop will give me the value, second value, that is 4. Okay. So this will get value now 4. Still high is 5, index is 14. So for the next time, we'll check this condition, we'll check this condition. Now bit value is 4. Now bit value is 4. And high is still 5. For 4, for 5. So we'll be getting at index, so we'll be passing it as 2. This thing we have discussed, just for the sake of dry run, we are passing index as 2. For 2 index, v value is having bit 1. High value will get bit 1. So now we'll check if bit v is equals to 0. So this is not equals to 0. So we'll come in else part. So in else part, we'll check if bit h high bit is equals to 0. No, it is equals to 1. So we'll be calling the right function. So we'll get count from right. So this get count function will get right of it. This count function will get right of it. So this is right. This right is pointing to null. So this will return 0. Now we'll call for left. Calling for left. First we have called for root, and value high was 5 and value was 4 and index was 2. Now we are calling for this 0, left, and 5, 4, index will be index minus 1, that is 1. So now again we'll come over here and we'll check the conditions. We'll generate the bit for value. So for index 1, value bit is 0. For 4, second index is having 0 and high index is having also 0. Now we'll check this condition if value is 0 and if also high bit is also 0. Then we'll be calling it left. Okay. So now calling it left 0, 5, 4, 0. Now again we'll come over here and we'll be checking all these conditions. We'll be generating bit for the 0 index. Okay, so at 0 index, 4 is having 0 and 5 is having 1. So bit v is 0 but bit h is 1. So we'll get into this function. Now it will count from the left. So from this, left is this and left is pointing to null. So this will return me 0. Now we'll call for the right. So calling for right, we'll get 5, 4 and index will become minus 1. Now we'll come into this function again. Then we'll receive index as minus 1. So this will return get count. This will call get count function and we'll pass this root. So this root is now pointing to 1. So now whatever, now this time root is not equals to null pointer. So it will return count of root. So this root is having count equals to 1. So this will return me 1. Now we'll return 1 from here, 1 from here and 1 from here. And ultimately we'll get a count of 1. So it means 100, that is 4, will get XOR with 1. 4 is getting XOR with 1 and it is receiving count as 1 for less than equals to 5 range. What we have calculated for the less than equals to 5 range. So count value has received 1 from here. Count value will receive 1 here. Now it will check the range of, now it will check the count for range less than equals to low minus 1, that is less than equals to 2. So now it will get what? it will get 4 XOR 1 for less than equals to 2 for this range. Now after this what will happen? See, now focus more, because now we are going to discuss very important thing. See, till now our root has inserted 1. Now we have checked for 4. Now after counting for less than equals to 5 range and less than equals to 2 range, we'll be inserting now 4. We'll be inserting 4 in our try. So this was representing our try. 1 was already inserted. Now we'll be inserting 4. So 4 value is 1, 0, 0. So now after getting count from this, we'll get what? We'll get 2. Now 2 will get XOR with 1 and it will be finding the count till range of less than equals to 5. Now 2 will get XOR with 1 for less than equals to 2, and also 2 will get XOR with 4 and 1 for less than equals to 5. For 4 and 1. Now 2 will get XOR with 4 and 1 for less than equals to 3. Okay, so we'll be counting for these two in a single call and these two in a single call. Now we'll insert 2 in our try. So it will get inserted 0, 1, 1. So 2 will also get inserted. Now we are having 1, 2 and 4. 1, 4, 2 we are having in our try. Now we will get 7. So 7 will get XOR with 2 for less than equals to 5 range. 7 will get XOR with, so this was less than equals to 2, low minus 1, less than equals to 2, low minus 1. So 7 will get XOR with 2 for less than equals to 2. 7 will get XOR with 4 for less than equals to. So see, 7 was get XORed with 2 for less than equals to 5. 7 will get XORed with less than equals to 5. 7 will get XORed with 1 for less than equals to 5. And then 7 will get XORed with 2 for less than equals to 3 for less than equals to 2. Less than equals to 2. So what we'll be doing, basically we'll be maintaining count in this. We'll be maintaining count. So basically we are counting for less than equals to 5 and less than equals to 2. And at last, so we are also maintaining count by subtracting. Whatever we get from less than equals to 5, subtracted from less than equals to 2. So we'll be getting in the range of less than equals to 5 and greater than equals to 3. This thing we have discussed over here. Okay. Now at last we'll be returning count. So now I hope you have understood the dry-run. See, we have not done the complete dry-run because it will get too lengthy. But I hope you have understood the rest of the things. But for practice, if you want to, then you can do the complete dry-run. Now we'll run our code. So there is some error. Okay, so there will be left and right. So count will be 0. Now let us run our code. Okay, so it is accepted. Let's submit it to check all the test cases are passed. So okay, all the test cases are passed. So I hope you have understood the question and the concept. So we'll be meeting in another video with another question. So thank you for watching.